Hello, this is Charlene. In this video, we're going to be talking about logarithmic functions. Um, the first thing we need to understand is the relationship. A logarithmic function is an inverse function of the exponential function. Below here, we can see that the exponential function follows this path, and the logarithmic function follows this path. And in between them, you can see that we actually have y equals x. So the line y equals x provides a line of symmetry because inverses are separated by the line of symmetry, and they are mirror images of each other across the line y equals x. So the next thing we need to know about logarithmic functions is that, like addition undoes subtraction, and vice versa, the exponential function will undo the logarithmic function, and vice versa. Logarithmic will also undo the exponential function. So the log function, this is an example, the way our basic standard log function looks like. The log function is equivalent to the exponential function. Probably the most important thing that I can tell you about logarithms is the log is the exponent. It's like the log is the exponent. So let's think about what that practically means. If this is what our basic log looks like, all of this part right here, this is the log base of some number or expression, is equal to or is the exponent. The exponent is on this side of the equal sign. So there's the equal sign. And my log is equal to that exponent. The log is the exponent. Okay, let's look at an example of this. I've got an actual log here. It says log base 5 of x is equal to 2. Well, based on what we just said, all of this is the log, and it is going to be equal to the exponent. So the 2 would actually be the exponent. Now, it doesn't look like it's the exponent here, right? But we're about to switch it up in a minute. We're going to learn how to change it because they are interchangeable. Let's grab this right here. Here is the exponential setup. So an exponential function looks like this. This is a log function right here, and this is what the exponential function looks like right here. And I can't write. Let's see here. Let's fix that. The exponential function looks like this. So we've got a base right here. The base is 5. Base is 5. But over here on the exponential, here's the base. So let's write that base right here. Let's write base of 5. Okay. And then the next thing is our exponent. So our exponent is on the other side of the equal sign. Our 2 is our exponent. And we're going to write our 2 in that exponent position. So it's going to be 5 squared now. And then over here, we have the number. This is what represents, some number or some variable or some expression. So the x represents the number or the expression. And here is where we're going to put that number on the other side of the equal sign. So that means that we're going to have is equal to x. Now, when I just converted it from the log version to the exponential version, where did that 2 land? Is the 2 an exponent now? Yes, it is. So the thing is that kind of confirms the fact that our log, all of this, is equal to or is the exponent, because now we can see clearly that 2 is the exponent. Our instructions tell us to write each equation in its equivalent exponential form. So basically, we're going to take this log form and we're going to convert it into an exponential form. So we're going to use our knowledge of how the log is set up and how the exponential function is set up in order to make that conversion. Okay, so we're going to look at all of our pieces first. after I get rid of this. There we go. Okay. So we're going to do log base. What is my base? My base is right here. So it's log base 3. And over here, it is the base. It's the base of the exponent, right? So we're going to go ahead and put a 3 as my base. And now let's find our exponent. Our exponent is on the other side of this equal sign. There's my equal sign. There's my exponent. So I'm going to write my exponent in the exponent position. So 3 to the power of 2. And then it's equal to the expression that is left over. So what is left over? We've got a number representing our expression, and it actually is an x. So we are going to put an x over here. Now, if we wanted to, we could go ahead and solve it. So what is 3 squared? It's 9. That 9 is equal to x. So even though our instructions didn't tell us to solve it, we did just solve it. So writing the equation in its equivalent exponential form is right there. That's the answer to the question. But we went one step further and we actually solved it. So if they come back later and ask us to solve this right here, we know how to solve it right there. Okay? Okay, the next one also wants us to write the log in its equivalent exponential form again. So our log says log base 5 of x plus 3. Remember I said that could be a number, it could be a variable, it could be an expression. This one has an expression. So log base 5 of the expression x plus 3 is equal to 6. Again, we know where all the parts and pieces of our log are. The base is right here, log base. So our base is going to be the 5. So over here in our exponential version, our base is right here. So let's go ahead and write our base of 5 right there. And then let's go find our exponent. So our exponent is over here on this other side of the equal sign because the log is equal to the exponent, or is the exponent. So it is going to be a 6. So we're going to write the 6 in this exponent position. So 5 to the 6th power, and then that's going to be equal to whatever's left over. It could be a number, a variable, an expression, and in this particular instance, it is the expression x plus 3. So 5 to the 6th is equal to x plus 3. And that is how we convert this. This is the log version, and this is, well, actually, this is the log version, and we have just converted it to its exponential version. So this is the conversion to the exponential form. Our next question wants us to do something a little bit different. It wants us to write the equation in its equivalent logarithmic form. So instead of starting with a logarithm and changing it to exponential, we're going to start with the exponential and we're going to move it to the log base. So we're going to start with the exponential version and we're going to convert it to its log form. Okay, so again, we got our standard exponential form, which is a base to an exponent, and it's equal to some number or expression, or it could be a variable. Okay, so in this one, we've got a base of 14. The 14 is in the base position because it is the base of the exponent. So let's go ahead and write that 14 in the base position. Okay, so that means we need to write the word log first. We're converting it to the log, and the base goes right here like a subscript to log. So it's going to be 14 log base 14. And then I usually like to go over here and put my exponent way over here. What is my exponent? So let's go find the exponent. My exponent, the base is a base to the exponent. My exponent actually is the x. X is in the exponent position. So that's what I'm going to do. I'm going to put x way over here on the other side of that equal sign. And then what is left? What's left over from that? Well, I've got whatever's left over is going to be in this position in the exponential form. So 2744 is what's left over, or the argument of the log. So that means I'm going to put 2744 right here. 2744. Okay, so now we have converted this exponential form into its log form right here. This one wants us to also write the exponential form in its equivalent logarithmic form. But this one's going to take just a tiny bit of extra work because it lists it as the fifth root of 16,807. So we just need to remember that if we have like the square root of x, that can be written as x to the 1/2 power because it is a square root. So we're going to rewrite this one as 16,807. And I can't write. Let's see here. Let's try to fix that. 1,600 or 16,000 um, 807 to the 1/5 power. 1/5 power, and that is equal to 7. Okay, so now it's much clearer. I have a base of 16,807, so that's my base, and I will write that over here, my log, with a big old base of 16,807. 807. Okay, and then I also have my exponent. My exponent I now know is 1/5. So in the exponent position, which is on the other side of the equal sign, because remember, our log is the exponent. So all of this log is that exponent. So I'm going to write it on the other side of the equal sign. My exponent is 1/5. And then what is left over? Let's see, I've got a number here representing what's left over, or the argument. This number here that's part of the log that's in this position is also referred to as the argument of the log. So we're going to put the argument. The argument of this log is 7. So we have now converted our original exponential form to its logarithmic form. This video has been brought to you by Connect the Dots Online Math Tutoring. Before you leave, click on the like button and the subscribe button, and have a wonderful day.